Okay, here we are back again with another video. This one is an example of how to find a domain of a function. I tried to pick one that was fairly complex, maybe relative to the others. Um, if you remember back in the original overview video when I talked about the major concepts, one of the things that we do is we assume that the domain of a function is going to be the largest possible set of real numbers for which the function is defined, right? So we run into two issues here as far as something being undefined, and that means if I put x into the expression here, take f of a number, it's going to lead me to something I cannot compute. Okay, it is we refer to that as undefined. Why couldn't we compute it in an expression? Well, there are two things we mainly need to worry about with algebraic expressions. And one is having negative values underneath a square root or an even powered root. So in this case, we're dealing with square root. So this expression, I can't substitute an x in here that's going to make it negative. So in other words, if I put zero, if I tried taking f of zero, zero squared is just zero. I would take 3 over negative 64. If I tried taking the square root of 3 over negative 64, I would get an error on my calculator. Now, if we were dealing with a set of complex numbers, that's a different issue. But right now, we're dealing with real numbers. So that would be a no-no. So the other thing would also be true is if I tried taking f of 8, if I put 8 in here and I squared it, I would get 64 minus 64. I'd be dividing by 0. And again, that's something we cannot do on the calculator. We would get error. There's just, there's no algorithm. It's just the mathematics. We can't divide by 0. It's an undefined number we refer to it as. So that's basically it. So the question is then, well, how do I find the values, right, for which the function's defined? Well, if you look over here, what I did is I just took that expression underneath the radical, and this negative doesn't really affect it because I'm just worried about, again, what's underneath here that would be negative and what's underneath here also would be, something that would give me 0 in the denominator. So what I'm going to do is I'm going to go back to solving inequalities, and you probably did this in the pre-calc course where you took an expression here, and I want to find out all x's where this is going to be greater than, in this shot, boy, I just realized that I should just have greater than 0. I don't want it to be equal 0. I mean, I'll find out where it's equal to 0. This isn't an issue here. I interpreted it correctly down here, but I want this thing to be greater than 0. And so that's since 3 is positive, right? I just really want to know where this expression here is greater than 0. So what I'm going to do is I write that down here to this next line, and I'm going to go ahead and factor this. This is called the test point method, and I'll make a number line for each factor. So here I have 2 of those, x plus 8 and x minus 8. And then I'll have a number line down here for the product of those two. All right, now what I want to do is put the key points in where they're equal to 0, and this one's equal to 0 at -8. This is equal to 0 at +8. And I'll take this expression, any number, it's equal to 0 when x is equal to -8. So I go over here and I pick a number to the right of it, like 9, 10, 11, 12, whatever. If I substitute, numbers greater than -8 in there, okay, you can put 0, even put -5 in there, it's going to be positive. So that makes this expression positive for numbers greater than -8. Numbers to the left of -8, it's going to be less than 0. Okay, so if I put like a -10 in there, a -20, and so forth. I'll do the same with the x minus 8, and my 0 point here is +8. Numbers to the right of 8 make this positive, and the left make it negative. Now, here's where I'm concerned. I want to know where the product of these two are positive and negative. So numbers on these intervals are always going to be positive. So I'll always take a positive times a positive will lead me to positive. Positive times negative will always lead me to a negative, and two negatives multiplied together will give me a positive. So that tells me this expression right here is positive for numbers greater than 8, and also for numbers less than -8. So I write it out like this here, x less than -8 or x greater than +8. Well, over here, then it asks me, it says, simplify your answer and type your answer in interval notation. So if I type this in, MyMathLab is going to mark it wrong, even though it's the correct solution. So what I'll have to do is, get out that palette here and type in, all of the formulas here, symbols that would be required to do that. The U represents the or, okay, the word or, that's just a mathematical symbol for the word or. And so I went over the interval notation in that first video there for the overview of the course. So here's how I write x less than -8. Here's how I write x greater than 8, and I connect them with the 4. Okay. Um, I talk about using graphing at various times here, and I just want to mention that real quickly. This is probably a problem that's done a lot easier using, an algebraic technique. If I did happen to graph this function over here, let's slide this up, you can kind of see that it implies there's a, vertical asymptote at -8, and you can see the graph to the left of it, and to the right of +8, the same thing implies a vertical asymptote at 8. That makes sense. That would be where it's equal to 0. Notice there's nothing in between. And, that's where you kind of get into the graph, like, well, is there somewhere else above here or below down here where that graph is defined, and there'd be some red somewhere in this region in between. We can look forever, and there's not going to be, based on our work back here, that we, again, found it, it's going to be negative here, so that it wouldn't plot any points because it wouldn't know how to take the square root of a negative number here. So I know there's going to be no points here just by looking at this chart. All right. So that wraps up this one here. Again, taking a fairly, I guess, complex problem in terms of finding domain of a function. There's ones that are a little bit, easier to go ahead and compute. I picked one of the more difficult ones to illustrate this to you, and know that graphing isn't always the easiest route to take. Sometimes algebra is, so it's always good to know all of those methods. All right, well, that's it for this one. And again, make sure you remember to use pause and scroll to, kind of pick and choose the parts that you want to emphasize, or maybe the ones that you don't understand, and review again. So, all right.